The next value that's really important is the transmission. Now we're getting to something that, yeah, the more the merrier. The higher the transmission, the brighter the image, the less gain that's required from the camera, and so the less noise that will be produced by the camera if it's in an auto gain situation. So we care about the transmission of the endoscope, and it's just like what you would think it is. It's the amount of light that's able to go through the lens system. We're not talking about the fiber optic illumination, and it's always with respect to some reference, and I'll be getting into that very much detail on choosing that reference. In a way, it doesn't matter, because what you're more interested in is saying, hey, I've got this new Stork scope, I've been using it, we can turn the light up to a reasonable level, I can see what I need to see in the center of the field. Now I just got this scope repaired, and I've asked the wandering nurse to turn the light all the way up, and I still can't see a bright enough image in the center. Next really important characteristic concerns transmission, and it's the uniformity of transmission. The technical word for that is vignetting. So again, the surgeon says, got the scope repaired, yeah, I can turn the light up and I can see what I need to see bright enough in the center of the image, but I used to be able to see what was going on at the edge of the field, and now I can't. It's always dim. And if I turn the light up more and I can see what's going on at the edge of the field, well, now the center of my field is saturated, and I've got a whiteout condition. I can't see anything. It's too much for the dynamic range of the camera. So this is actually a very difficult part of the optical designer's task when they're designing an endoscope, to have a very small level of vignetting, which translates to a high uniformity of the transmission. You can think about it, kind of logically. If I'm, putting the light through here and it's going straight through the lenses, yeah, that's a lot easier than getting all the light that's going up and down, getting through the lens system. And it's the lens designer's job to reduce the amount of vignetting to a small value. The tint of the image. Is it yellowish? I call this coloration. Again, this is a pretty straightforward kind of concept. You've got something flesh-colored, you want it to translate flesh-colored through the optical system. Oftentimes, the glasses won't transmit blue as effectively as the other colors, and a lack of blue means kind of a yellowish image. The anti-reflection coatings on the individual lens components in an endoscope, when you have 30 air-to-glass interfaces and you're off in your anti-reflection coatings by a very small amount, it can drastically adjust the tint of the image. If the repair organization puts in new lenses and they don't have the proper anti-reflection coatings, you can have the effect of having a yellowish image.
Measuring endoscope brightness is a completely automatic operation. Simply insert the target, adjust the distance so that the edge of the field aligns with the circle, Click TVC to start the measurement, and all measurements, brightness, vignetting, and coloration are done simultaneously.